13.3, the unit circle. The definition of a unit circle simply means, we've already been drawing and using circles, but a unit circle is a special case where the radius is 1. That's why it's called the unit circle. The radius of the circle equals 1. And all of our trig functions still are defined the same way, but when the radius is 1, a nice little simplification happens that makes things handy. So if we draw a unit circle, and we'll fill out the handle in it, the handout in a second. Then when we rotate, say we rotate to this point, we rotate our angle, we rotate to that point, right? And so we're just going to draw, what it means is this hypotenuse, first we have to make our right triangle, right? We drop the line down with the x-axis. There's our right triangle. This is still theta, right here. We rotate theta. All of that's the same. All of our trig ratios are the same. There's theta. But this side length is 1, if it's a unit circle. It doesn't have to be, but in the unit circle, the radius of the circle is always 1. Therefore, now we still have a point xy. So this distance is x. We go to the right x and up y. But there's something cool that we can say about the coordinates, not just x, y. There's something related to the angle. This is here now. And this is a nice thing works out with the unit circle only for the x and y coordinate related to the angle, and we can test it out too. So what happens is, watch this. What is the sine of the angle? Look at the picture. Do you see that? It's just y. It's not even y over 1. I mean, y over 1 it is, but 1 is just simplifies. So the y coordinate is the sine of the angle. And I'll show you in some examples in a second. So, and what about the cosine of the angle? The cosine of the angle is the x coordinate. So if you want to know in a unit circle how far you traveled to the right and up, you would take the sine of the angle and the cosine of the angle, and you can do it on your calculator. So let's try one. So here I'm going to write the x coordinate is the cosine of theta, and the y coordinate is the sine of theta. So let's do, so I actually want to write that in words. In a unit circle, well, I said it. The sine of the angle is the y coordinate. So this is like the x coordinate, and this is like the y coordinate. So let me show you something. So let's say, oh, and we still have x squared plus y squared equals 1, right? You can see it in the picture. But instead of writing it that way, we're going to, one of the most important, it's called the Pythagorean Identity, is instead of that, we would say cosine squared plus sine squared equals 1. And we use this is called the Pythagorean Identity, and we use that theorem all the time, Pythagorean Identity. So let's look at an example. So let's say I draw this circle with radius 1, and I want to know, I rotate, say, 10 degrees, okay, and I want to know what the coordinates are. Let's just say theta equals 10 degrees. So go ahead and take the cosine of 10 on your calculator. Since the radius of the circle is 1, what would your guesstimate be on these coordinates? If I rotate 10 degrees like that, what do you think roughly the answer is? In fact, what are the coordinates right here? In the xy coordinate plane, how far to the right and up do I go to get to here?
1, 0.
Very good, 1, 0, exactly. So what do you think the coordinates are here? Well, it's hard to say, but take the cosine of 10 degrees. That'll give you the x-coordinate. What is it? Is it greater than 1 or less than 1? It has to be less than 1 because you don't move quite as far. The most to the right you can move in quadrant 1 is 1 in the radius, in the unit circle, right? So what's the cosine of 10 degrees? 0.9, okay, 0.98, okay, good. And what's the, if I want to know how far up do I go, what's the sine of 10 degrees? Just, what is it? 0.17. That sounds totally reasonable. Do you see that? So you can get the coordinates of a point on a circle. How far to the right do you move and how far up? 0.98, 0.17. If you just take the cosine and the sine of 10 degrees. Yeah. Okay. So so what we can use this for is to evaluate. Now we can quickly say, so we're going to evaluate trig functions again, but we're going to be able to do it with the quadrantal angles. And those are the ones that are on the quadrants. So 0 degrees, 90, 180, and 270. Because if you try to do this the old way where you draw the triangle and make a right triangle, there is no right triangle. So let me show you, for example, let's do 270 degrees. Theta equals 270. Let's say we're naively trying to do what we did before. We draw a picture. You would rotate to, 270 degrees is there, right? Okay, so now we're going to try to drop the line to make a right triangle. It's not going to happen, right? Here's theta. You rotate around 270. There is no right triangle. But if I want to know the cosine and sine, the cosine of theta equals, well, that is the x-coordinate. So what is the x-coordinate for this? In how far to the right do I move to get to this point? 0. And how far up or down? Think about the unit circle, right?
1.
-1. So the cosine of the angle is the x-coordinate, so that's 0. The sine of the angle is the y-coordinate, which is -1. And you could even check on your calculator. You could take the sine of 270. It's -1. And then the tangent, let's say the tangent is just sine over cosine, so -1 divided by 0. This is interesting. What's -1 divided by 0? Can you divide by 0? No. If you tried on their calculator, you would get undefined. So the tangent of 270 degrees is undefined. Did I do that wrong? No, that's right. Yeah, undefined. Okay, and then when we want to take the reciprocal, the secant goes with cosine, right? If you take the reciprocal of 0, that's like saying 1 over 0. Because 0 is the same as 0 over 1, so if you take the reciprocal, what do you get for the secant of 270? Undefined, right? The cosecant, what's the reciprocal of -1? It's still -1. And the cotangent, the reciprocal of undefined is, yeah, it's 0, right? So those are always reciprocals. Undefined and 0 are always reciprocals. So what we can do now is to find any, this would be the last, well, almost the last new thing today, is we can fill out this unit circle. And we can do the cosine and the sine for some key angles around the unit circle. But I think that I'm going to save that. And we're going to do the last objective for 13.3. So, yeah, the last objective for 13.3 is finding reference angles. And should we fill out the unit circle first? Let's fill out the unit circle first, and then we'll find reference angles. Okay, so let's go back to this. So I'm going to use a pen here. All right, let's do this. Let's fill out this together so that it makes sense to you. So this, how many degrees are right here? How many degrees? Let's go around the circle in degrees and then radians. How many degrees? 0 degrees. Okay, so everyone's filling this out. How many degrees are here? That's a 90-degree angle. And this is how many degrees? 180. And good, 270. And then these are from the special right triangles. So the first one is going to be 30. This is going to be from your 45, 45, 90. And this, how many degrees here? Are 60, yes. Now everything is relative to this quadrant, so as we go around, do you see how these are all 15 apart? So this is 90, let's see, 30, well, let's go around in terms of the right in the middle. So 45, 90, what's in the middle here? 135, right? And if we add 45, we would get 180. If you add 45 to 180, you get 225. This is 270. Add 45, you get 315. Nice. So those are all of the ones in the middle. Now let's go by, we can finish by just going by 30 degrees. So 30, 60, 90, this is 120, just add 30 degrees. Add 30 to that. You get 150. And then add 30 to this. 210, and then add 30. Add 30, add 30. 300. And then good, 330, and then this is okay, so now let's do radians. So this is 0 radians. How many all the way around? One pi, or okay, you have to know that it's 2 pi radians, 6.28, right? The circumference of a circle is 2 pi r, 2 pi radians. So therefore, what's halfway around in radians? Yep. And what's then what goes here? What's half of pi? Good. So let's do all those first. So we have 0, a half pi, 1 pi, so what goes down here? 3 pi over 2, right? Radians. Okay, good. Let's go by fourths. So this is a half, so what's in the middle here? Half of a half is, yeah, pi over 4. So this is a half, so in the middle here is, what's between a half and 1? 3/4. So 3 pi over 4. 4/4. This is 5/4. 5 pi over 4. 6 pi over 4. This is 7/4. And this is 8/4. Right? 8/4 is the same as 2 pi. Okay, and now, so let's do, okay. So 30 degrees, if you multiply that by pi over 180, can you simplify that? 30 over 180 simplifies to 1/6, right? 30 goes into 180. Remember I said to go from degrees to radians, you multiply by pi over 180? So this is 1/6 pi over 6. And this one is 60 degrees. 60 times pi over 180 is pi over 3. Good. Okay, so if we go by 6, we can get all the radians. 1/6, 2/6, 3/6. This is 4/6. Can you simplify that for me, though? 2 pi over 3. 5/6. That's already simplified. 6/6. Okay, good. Yeah, 6 over 6 is 1. 7/6. 8/6. Oh, 8/6 simplifies to 4/3. 9/6, that's 3/2. We already got that. 10/6, which simplifies to 5 pi over 3, and 11/6. And finally 12/6 is 2. So we can go around the circle. We can define an angle in terms of degrees or radians. You can convert. And now all we need are for now is the coordinates. So it's a unit circle, right? Unit circle. Maybe right here radius equals 1. So what are the coordinates of this point? If it's a unit circle, how far do you move to the right and up? 1, 0. Those are the coordinates, right? And what are the coordinates here? Very good. 0, 1. You have to be able to picture this in your head. What are the coordinates here? It's a unit circle. Remember, this is 0, 0, the origin. What are the coordinates? -1, 0. It's the radius of the circle is 1. Don't forget that. So you can't go any further than that. So -1, 0. What are the coordinates here? 0, -1. Okay, good. Now, we really only need to focus on quadrant 1 right here. Remember, write this at the top. Really important. We just did this in your notes. Write this at the top. The cosine of the angle is the x-coordinate, and the sine of the angle is the y-coordinate. So, for example, right now, using this reference, because the book's going to say do it without your calculator, if I want, like, the cosine of pi over 2, the answer is 0, because that's the x-coordinate. So at 30 degrees, based on the work you did with the 30, 60, 90, if I were to draw a right triangle in here, the coordinates are, if you just solved, it would be √3/2, 1/2. If you solved a 30, 60, 90 where the length of the hypotenuse was 1, this side length would be √3/2, and this side length would be 1/2. If you solved a 45, 45, 90 where the hypotenuse was length 1, you would get √2/2, √2/2. These are things that you would memorize this in math analysis. You would memorize this whole circle. And then this, if you, again, it's a 30, 60, 90, but now a different side is radius, a length 1, so you basically just reverse these. Instead of √3/2, 1/2, it's 1/2 √3/2. So it's easy to memorize because it's just, you just switch x and y. Now, watch what happens. The rest of the unit circle is super easy to fill out because it's mirror image. Do you see how, like, let's take this one. If I move to the right 1/2 and up √3/2, all I have to do to get here is move to the left 1/2 and up √3/2. So the coordinates are identical, it's just that the x-coordinate is negative. So you basically copy this over here. So this is negative √2/2, √2/2. And this is negative √3/2, 1/2. Does everyone see that? Because that's rectangular motion, right? Everything in this quadrant is positive, positive. Everything is positive, right? In this, it's negative, positive. Can you guys just cross this out? In this quadrant, it's, what is it? Tell me. In quadrant 3, what are the signs? You move to the left and down, so it's negative, negative. And in this quadrant, it's to the right and down, positive, negative. That's right. You already knew that from Algebra 1 when you plot points. So just cross this stuff off. And we're going to fill in the rest is just, you know, it's just mirror image, right? So here, if you move to the left and up, you move to the left and down to get to here, so it's the same. You copy this right here, it goes right down here. Except it's negative root 3 over 2, negative a half. And this is negative root 2 over 2, negative root 2 over 2. A lot less memorizing, right, when you see patterns. And this is negative a half, negative root 3 over 2. And this is, let's see, here I'm going to copy from here. It's the same distance from the x-axis, so positive root 3 over 2, negative a half. What's this? What are the coordinates here? Root 2 over 2, negative root 2 over 2. And here are?
1/2 negative root 3 over 2.
Exactly, 1/2 negative root 3 over 2. So when you have this in the book says, you know, don't use a calculator. What's the cosine? You tell me, let me quiz you. What's the cosine of 5 pi over 6? Just look at it. What's the cosine of 5 pi over 6? Here's 5 pi over 6. We want the x coordinate. What's the answer? Negative root 3 over 2. So if I say, what's the sine of 60 degrees? What would you say?
3 over 2.
Root 3 over 2. What is the cosine of 2 pi over 3? Negative 1/2. That's right. And so if there isn't, if you get this whole thing in your head, which any calculus student has this whole thing in their head, you could quiz me on it. I could tell you any of those answers. You want to get familiar enough with this. Really, all you have to memorize is quadrant 1, right? Because everything is a mirror image. And so I have to show you one more thing to finish this section now. And it's called finding the reference angle. Because of this symmetry, whenever I have a complicated angle, like say 150 degrees, what the equivalent reference angle is 30 degrees. Do you see that? Reference angle means find the angle in quadrant 1 that's the same distance from the x-axis. Because that allows you to use the only thing you have to memorize is quadrant 1. Everything else is symmetric. So let me try it. Maybe we won't take notes on it. I don't know. What's the reference angle of 7 pi over 6?
2 pi over 2.
Okay, what angle in quadrant 1 is the same distance from the x-axis as 7 pi over 6? That's right. You keep it in radians. If you're given it in radians, you keep it in radians. What's the reference angle of 5 pi over 3? What's pi over 3? Do you see that? What's the reference angle of 330 degrees? 30 degrees. Well, okay. What's the reference angle of 11 pi over 6? Pi over 6. Right? So all you have to do is figure out how far it is from the x-axis, and that's the answer. So let's try it that way. Like 135 degrees, how far is that from the x-axis? How many degrees? 45 degrees. And that's your answer. So that's what it means. So I have to at least write the definition of reference angle, if not to do some examples. So reference angle means, it's super important to be able to find the reference angle. The reference angle means the angle in quadrant 1. The angle in quadrant 1 that is the same distance, to the x-axis. So for example, Let's say I want, what is the reference angle of 210 degrees? It's very helpful to draw a picture, to picture where 210 is. Well, so here's 180, 210 is a little bit past, right? So how far past the x-axis is it? So that's 210 degrees, right? How far from the x-axis is it? Very good. Your answer is 30 degrees. Let's try this. Let's try negative 7 pi over 9. Well, that's not even on the unit circle, actually. But we can still do it. So negative 7 pi over 9 is close to negative 1 pi, so it's somewhere in this area. You really need to know which quadrant it's in, because negative 7/9 is less than 1, and you know pi is here. So how far is that from the x-axis? What's that? In radians. If you're given it in radians, you have to stay in radians. How much further do I have to go to get to the x-axis? Think of the fraction 7/9. How much more do I need to get to 1? 2/9. So the answer is 2 pi over 9. And that is the equivalent, 2 pi over 9 is the equivalent angle in quadrant 1 that's the same distance from the x-axis. 2/9. That's about as hard as they get. Let's try one more, and then I will stop. Let's try negative 260 degrees. So you would rotate negative 180 plus what? Plus 80 more, right? So that's what negative 260 looks like. How far is it from the x-axis? 80 degrees. So that's the answer. That's the reference angle. Because you want, now keep in mind 80 degrees is not on the unit circle, so I wouldn't ask you to find the sine or cosine without using your calculator. If it's on the unit circle, you should be able to do it without your calculator. Otherwise, you're going to need your calculator. We only use the unit circle because it's convenient, because it makes answers turn out nicely.